Okay. All right. I'm still thinking about this toolbox just a little bit here. The Chapter 3 toolbox has a few other skills here. One of them is good old factoring. Again, I'm not here to, well, I'm here to help you with all kinds of math. But I don't feel like I'm teaching you factoring. I feel like I'm reminding you of factoring. But students have a tough time sometimes. Let's see. Watch this. See, if you just wanted to factor this, factoring, it's kind of like undistributing. So I want to undistribute this or factor this. And so what I'm looking for is, what do these two terms have in common? What is a factor they have in common? Any ideas?
4x squared.
A 4, good. And so I was thinking sort of separately that they have a 4 in common. I could factor out a 4. But when it comes to the variable, you're right. There's an x to the 4th and there's an x squared. So I could factor out an x squared. So I can factor out a 4x squared, you're saying. Okay, all right. So I factor it out, and what am I left with? Then you play this game called What's Left. That's what I call it. So if you factor out the 4, it's gone. If you factor out an x squared using the rules of exponents, I think you're left with an x squared. Because if you multiplied them back, you would add exponents, you would get back to that. What happened here? You factored out the 4, and you factored out the x squared, so I think you're just left with the number 2. You guys agree?
Yep.
And if you distribute it back through, you get back to this. So that's factoring. But that's just one kind of factoring. There's also, there's this. There's this. This doesn't have anything in common, so I'm not going to do this. I'm not going to pull out a common factor. That was different. That was this. This was pull out a common factor. Factor out the greatest common factor is what it's called. Yeah, this one doesn't have a greatest common factor. I can't really do that. So this is a special factoring thing. You probably heard of it. It's called the difference of two perfect squares. And if it's the difference of two perfect squares, it factors into these two binomials. One of them is 2x minus 3, and the other one is 2x plus 3. Did you know that? Maybe you didn't. Maybe you didn't. You should. This is kind of special factoring called the difference of two squares. How do you know it's true? How do you know you did this right? If you FOILed it all back out, you would get this. If you multiplied it all out, you would get this. If you multiplied all this out, you would get this. By the way, if you ever see the sum of two squares, look at this. The sum of two perfect squares. It doesn't factor. You're stuck. It's like, so it's prime. It doesn't factor. The sum of two squares doesn't factor. The difference of two squares factors. But then there's the old typical, these trinomials that factor like this. X squared minus 5x minus 6. And if it's a trinomial, they don't all factor. Some of them just don't factor. But some of them do, and if it factors into these two binomials. And the first two terms have to multiply to be x squared. It's got to be x and x to multiply to be x squared. The last two terms have to multiply to be 6. What multiplies to be 6?
2 and 3.
2 and 3. 6 and 1. That's about it. But somehow they gotta, when you do your FOILing, your inners and your outers gotta add up to this negative 5x. A lot of students get this one wrong. They think of the 2 and 3 automatically, and but that's not going to work on this one. Because of the signs of these numbers here, I I think I need a -6 and a +1. The last two numbers have to multiply to be -6. I think I got that accomplished. And then when you multiply the inners and the outers, does that add up to your middle term? It's a 1x and a -6x. A 1x and a -6x is a negative. Yeah, we got it. It's factored. It gets worse, of course. How about this one? Wait a minute. Don't look at the man behind the curtain. Look at that one. Yikes. It probably factors though. It's a trinomial. And I just made it up. It probably factors into two binomials. Listen, you probably get partial credit if you just do this. Not much. But this is how you should start. It factors into two binomials. Write down a couple damn parentheses. And then start filling it in. It's probably a 3x and an x. It's got to be a 3x and an x. It's the only choice. Now what? Could be an 8 and a 1. Could be a 4 and a 2. Oh boy, oh boy, oh boy. 4 and 2. 4 and 2. How about a -4 and a +2? Now, how did I figure that out? Because I saw a -12x. Y'all see that? -12x. See that? And a +2x. What's a +2x and a -12x? -10x. We got it. We factored it. Cool. Why are we doing all this factoring? Back to parabolas. If I go back to parabolas, quadratic functions, then the reason I want to factor is because I might want to do this. You ready? Find the x-intercepts. So when I do this, when I start finding x-intercepts, so I just jumped out of the toolbox. I'm sorry, you guys. I did some factoring in the toolbox, and then I said, why are we doing this factoring in the toolbox? Because if we jump up to 3.2, if I jump up to 3.2, they finally get me to find some x-intercepts. And how do you find an x-intercept?
Y equal to 0.
You let y equal 0, and you proceed to solve a quadratic equation. Now, we haven't done this yet today, but again, maybe you know how to do this, but this is, I feel like I should help you here. How do you solve a quadratic equation? Well, maybe you can factor it. That's what factoring is kind of for. It helps you solve a quadratic equation. Maybe I can do some factoring. This is not this, it's not this. There's different kinds of factoring that we try to be good at all of it. This is the most simple factoring. And it's so simple, some students don't get it. But it's the first one I did today, where you simply factor out a common factor. Factor out a 3x. What does that leave me with? 2x minus 1. Do you agree with that?
Mm-hmm.
If you multiplied it back, you would have that. So I factored this out. All right, here comes a concept. When you have this thing factored and it's equal to 0, I mean, here's the concept. You have this thing. You have two things multiplied and the answer is 0. It's very logical. If two things are multiplied and the answer is 0, what's got to be true? If two things are multiplied and the answer is 0, one of those better be a 0. And so that's why the next step is set each factor equal to 0. Maybe this is equal to 0, or maybe this is equal to 0. When you have factors multiplied that equal 0, you can set each factor equal to 0. That's the phrase. Dude, now you can proceed to solve for x. Any suggestions right here? I'm going to proceed to solve for x. Please tell me to divide by 3.
Divide by 3.
Thank you very much. If you divide by 3, you divide by 3, the answer is 0. That's one of the answers. Some students think that's not a real answer. They don't bother, or they screw it up somehow, or they subtract a 3. I mean, I don't know. Well, people do all kinds of weird things. Anyway, the answer is 0 for that. That's a legitimate answer. What's the other answer? Move the 1 over, divide by 2. The other answer is 1/2. You guys with me? I just found the 2 X-intercepts. Hey, 2 X-intercepts? Our lines never had 2 X-intercepts. Our lines only had 1 X-intercept, maybe. But these are parabolas, you guys. These are parabolas. It makes sense that they might have 2 X-intercepts. One of these X-intercepts is at 0, x equals 0, right there at the origin. The other X-intercept is at 1/2, right there next to it. I'm going to call that 1, so there's 1/2. Yeah, those are my 2 X-intercepts. That's interesting. I got a parabola that goes through there. Hang on, where is my parabola? There it is. Does it open up or does it open down? It opens up, okay, because of that positive 6. By the way, that 6 makes it skinny as hell. This is a skinny as hell parabola. But I got a blown up picture here. But here we go. You're saying it opens up, so roughly, there's a picture of this parabola. Why is it roughly? What did I found those 2 X-intercepts. What did I not do?
Find the vertex.
I didn't find the vertex. So when I decided to turn around right here, I just was totally guessing. I don't know where the vertex is. Maybe it's further down. Maybe it's not quite as far down. Maybe it's further down. You know what I mean? I don't know whether I didn't bother to calculate the vertex. Maybe I should. I'll tell you one thing. The x value of the vertex is, I know the x value without even doing any damn math. Sorry, my picture got messed up here. But if that's 0 and that's 1/2, guess where the x value of the vertex is? If that's 0 and that's 1/2, the x value of the vertex is right in between, dude. It's right in between the, yes it is. These parabolas are perfectly symmetric. So if you got the x-intercepts, the vertex is right in the middle. The x value of the vertex is right in the middle. So the x value is guaranteed to be 1/4. I don't know what the y value is, right? That's the part I really didn't know. I don't know what the y value is. I could find it. How do you find the y value of a vertex? If you have the x value, you can plug it in, right? If you want the y value of a vertex, you can plug it in. I'll just do that. So I found the x value not with the formula, just by being smart. But now I'm going to plug it in. Oh God, that means I got to go 1/4 squared minus 3 times 1/4. I'll tell you what, a calculator is kind of convenient here in chapter 3. That's a 0.25 squared. I could call it a 1/16. I could call it 6/16, I guess. Right, you guys? 1/16 times 6 minus 3/4. What the heck is that? That's actually 3/8 minus 3/4. Maybe I should get a common denominator. You wouldn't if you had a calculator, you'd be decimalizing all this. It'd be a little easier. I'm going to make it 3/8 minus 6/8. I think I'm going to get a negative 3/8 as my y, what is that?
Y.
Y? Well, no.
Oh, no, the y coordinate.
Good, thank you. I almost screwed up and said y-intercept too. It ain't y-intercept. I cautioned you about that. This is the y value of the vertex. The y value of the vertex. It ain't the y-intercept. Cool. Cool. By the way, that's right. Whatever. That's about right here. That was kind of weird. I wanted to practice finding the x-intercepts, but afterwards I decided, let's go find the vertex. Usually I find the vertex first. You know what? I think I'm going to, I mean, there's definitely a lot more to say about 3-2 because a lot of things just don't factor. And if it doesn't factor, we need the quadratic formula. Yeah, we got some more good stuff to learn. I'm gonna save some of that till next week. So I'm gonna stop today. And I'll see you next Tuesday.